Trigonometry is about the measurement of triangles. In Foundations of Math, we're going to deal with a right-angled triangle. We mark the angle BCA as the right angle, and opposite the right angle is the hypotenuse. Next, we're going to touch one of the acute angles, and we're going to label the sides. You can pretend that you're massaging the angle, and the angle responds by saying, "Ah." You are touching the adjacent and the hypotenuse. Label the other side the opposite. The key is the angle that you're referring to. It doesn't matter whether I've turned the triangle upside down. The sides that I am touching are the hypotenuse and the adjacent. Sine, cosines, and tangents will confuse you if you do not understand the properties of similar triangles. In similar triangles, the ratios of corresponding sides are equal to each other. Let's investigate this property now. Here is a right-angled triangle. The legs are length 8 and 12. They make the right angle. Let me make a new triangle that's half the original size. I'm going to take half of the 8 to get 4 and half of the 12 to get 6. And now I'm going to look at the ratio of sides. On the larger triangle, the ratio of 8 over 12 is equal to the ratio of 4 over 6 because we reduced it by 1/2. Notice that both fractions reduced to 2/3 in lowest terms. Let's see if this also works if we take 3/4 of the size of the triangle. Listen to the words. When I talk about 3/4 of something, I'm going to find out what 1/4 is and then take 3 of those. 1/4 of 8 is 2, and 2 times 3 is 6. 1/4 of 12 is 3, and 3 times 3 is 9. This is just a little bit of review of fractions. Look at this ratio. It is 6 over 9, which is 2/3. We form this ratio from taking the side opposite of the angle that I'm looking at and dividing it by the adjacent side. I could have formed many different ratios from two sides, and we have to be able to distinguish the kinds of ratios that we are talking about. The three basic trig ratios are sine, cosine, and tangent. The one I just created is called the tangent ratio. It is defined as the opposite side of the angle divided by the adjacent side. So the tangent of angle A is 8 over 12. 8 over 12 reduces to 0.6 repeater. Let's go back to another property of similar triangles. The size of angles remains unchanged in similar shapes. The size of angle here, here, and here is the same for all three triangles. All three triangles are similar. The angles remain unchanged. That means that this angle is unique and that we can actually find it. We can find it by measuring it, and if we look at the protractor that I've put on the diagram, it's going to be about 34 degrees. Other ways of finding it is to look at trig tables. Here I've downloaded one from the internet, and I've gone down the tangent column until I find the tangent of the angle, which is 0.66. So it's in between 33 and 34 degrees. Of course, you're accustomed to using a calculator. To find the angle A, we go inverse tan, bracket, 2 divided by 3, close the bracket, equals. This gives the result 33.6900 and so on, degrees. Or if we round it off, it's 33.7 degrees approximately. Let's look at other ways to combine the sides. Here's our original triangle with the sides 8 and 12, and I'm going to reduce it to 1/4 the size, or 2 and 3, and then I'll use Pythagoras to calculate the hypotenuse as the square root of 13. I've labeled these sides adjacent, opposite, and hypotenuse. Don't forget, the way we label it all depends on which angle I touch. Now let's define the other trig ratios. The tangent ratio is the opposite over the adjacent side. Well, we can do another combination where we take the opposite side and divide by the hypotenuse. We call this ratio the sine ratio. If we choose to take the adjacent side and divide it by the hypotenuse, we have now defined the cosine function. These three trig ratios are very, very powerful in solving trig problems. We use SOHCAHTOA to help you remember the order. So for sine, it's the opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent.